Lattice
Uh, I didn't copy full. I didn't copy full detail.
lattice enthalpy is a measure of energy release when you form a lattice. When you form a lattice, and what is a lattice? Lattice is an assembly of oppositely charged ions.
Okay, copied.
Definitions are for memory, and now we come to lattice. An ionic lattice is a three-dimensional repeating arrangement of oppositely charged ions. Look at this one. This is called lattice enthalpy. This is the simplest diagram. This is the
Simplest.
simplest diagram of a lattice. Can you notice that positive ion is smaller and negative ion is bigger?
Yes.
Okay, this is how the lattice, or this is how the ions fit in each other.
Okay.
Okay, now you have to copy this one. This is our second concept for today, that what is an ionic lattice?
Okay. Yes, copied.
So an ionic lattice is a 3D repeating arrangement of positively charged ions.
Oppositely.
Examples,
Oppositely. It was
examiners,
opposite.
sorry,
It was oppositely charged. And you said positive. It was oppositely charged.
oppositely charged. I'm sorry. Very good correction. Acha, in our AS level, we had a chapter bonding,
Yes,
and that
yes.
was yes, that
Ionic
was
bonding.
a chapter in our AS chemistry. So there we had this concept of ionic lattice. Now,
Yes.
this is the simplest structure of an ionic lattice. This is a 3D version. This is a 3D version. This is also a 3D version. So lattice
Yes.
is a repeating structure of ions. So you have to copy now this screen for rough drawing.
Okay.
How we can show the lattice in paper. Remember, lattice enthalpy is the most important definition in this chapter. A2 is very formal. So some definitions are very important. They come every year. You obviously
Okay.
have now the past paper book, topical paper. So when you
Yes.
open the book and you start doing the questions, you will
Yes.
identify, you will identify that some definitions come every year.
Yes. Yes. Copied.
So now we move to our next concept, how we write down the equations. Equation of formation.
Let us help. Like Na plus Cl, so NaCl, A plus Cl, KCl, Mg plus
But
Cl,
the main
MgCl2.
important thing, Wissam, the main important thing is the gaseous ions.
Yes.
Sodium by nature is a solid, but it should also be in gas. Chlorine is naturally gas, but it is not Cl. By nature, it is Cl2. So you
Okay.
can notice them that these are atomized particles, separate particles. Now you have
Yes.
to copy this.
Okay.
State symbols are critical. State symbols are critical.
Yes. Yes. Copied. Copied. Copied.
Now, our third concept, lattice enthalpy is exothermic in nature.
Yes.
You have to copy this.
Copied.
Now, factors affecting lattice enthalpy. I already mentioned that lattice enthalpy is the main topic of this chapter. It's a main topic. In A2, in every chapter of A2, there is a driving topic. So this is the driving topic. So you need to be very, very hardworking on this topic. What are the factors affecting lattice enthalpy?
The number of electron shells it is basically the
Look at the screen. Amount of charge on the ions. So make a concept, use physics. Plus and minus attract each other. You know that. So when you form a lattice, how the lattice stop? Can you look at this screen and can you tell me that do you expect electrostatic force of attraction between them?
yes, because it is oppositely charged ions, that's why.
Perfect. Now you got the point. So lattice depends
Physics,
upon
my old friend physics.
yes, amount of charge on the ions. Number two, ionic separation. This is also coming from physics. If the ions are close,
Yes.
they will apply more force. And if the ions are distant apart, they will apply less force. You have to copy the screen.
Okay. Yes, copied. Copied. Copied.
Now look at this screen. These are called data values, and in the paper, examiners are very habitual where they are very fond to give you data and ask you questions. Their chemistry is very friendly because it comes from the memory. You can look at the example, sodium fluoride. Look at the example, for example, sodium fluoride 788. Look at magnesium oxide 3795. Now you can see that magnesium oxide has an exceptionally high enthalpy change. Why it's so high? Because magnesium oxide is +2, -2.
Okay.
Sodium chloride will be +1 and -1. So it means if the charges are higher, the enthalpy change would be greater. If the charges are higher, enthalpy change would be greater. Look at this example. Oxygen has -2 and magnesium has +2, such a big number. But you can see fluorine -1 and potassium, so a much smaller number. So greater the charge, greater is the lattice enthalpy. Smaller ions will have a greater attraction for each other because of their higher charge density. They will have larger lattice enthalpies and larger melting points because of the energy which must be put into separate the oppositely charged ions. So smaller ions will have a greater attraction. Do you remember the concept of charge density? Charge density is related with the size. Smaller ions are more attractive, more powerful in terms of attraction.
Yes.
So what is the concept? Smaller ions
have greater attraction.
smaller ions have greater attraction and they can form stronger lattice.
Yes.
So lattice enthalpy depends upon the size of the ions. If the ions are smaller, they will
Yes.
be more attracting. Now,
Yes.
smaller ions will have a greater attraction. You have to now copy this screen.
Copied.
Now look at this. Sodium chloride is 788, but potassium chloride is 701. Why? Potassium chloride has less energy than sodium chloride. They both are combining with chlorine. Then why potassium chloride is less energetic, less energy of lattice than sodium chloride? Look at the size. Can you see potassium ion is bigger than sodium ion? Please reply, Faisal. Can you hear me?
Sorry by mistake. It was, I don't know how unmute that. So no. It is because potassium ion is bigger in size compared to sodium ions.
So it means now what is the concept? Bigger ions form weaker lattice. Smaller ions form stronger lattice.
Yes.
Can you repeat? If you have copied it, can you read? Smaller ions will have
Ions will have a greater attraction because of the high charge density.
of the higher charge density. It
Let
means
me copy this.
smaller ions form stronger lattice.
Yes.
So now what is the idea to remember?
Ions will have a greater attraction because of high charge density.
Smaller ions form
Yeah.
smaller ions form
Stronger attraction.
stronger attraction, and in the final output they will form stronger lattice. Okay. Smaller ions form stronger lattice. Copy
Yes.
this also.
Okay.
Now, if the lattice is strong, if the lattice is strong, will the material, the substance will be having
Yes.
higher melting point or lower melting point?
Yes.
Let me know. You have to tell me.
Can you repeat the question?
Stronger lattices, do they
Yes.
have higher melting point or lower melting point?
Let's have lower melting point, I think so.
Lower melting point or higher melting point? If the lattice is strong, will it be higher MP or lower MP?
Higher.
Sorry, higher,
Higher.
obviously. It should be higher because lattice is strong, so it's difficult to break.
Yes.
Now, sodium chloride example, sodium chloride enthalpy change is 788 and potassium chloride lattice is 701.
Yes.
Now you have to copy this example.
Okay. Yes.
Trends in lattice enthalpy.
Yes.
You have to copy this heading now.
Okay.
Trends is something very common in A-level chemistry. Trend means what happened down the group, what happened go in a
Across a
period.
period. It increases across a period, decreases down the group.
So you can look here. If I ask you to keep a periodic table with you, you can ask, I can ask you here, look at this box. Can you
It is.
see?
It is. Sorry.
Can you see lithium is fixed?
Yes.
Fluorine, iodine. Is it group 7? Group 17?
Yes.
Group 17, right? So if
Yes.
I go down, look at carefully, lattice enthalpy is increasing or decreasing?
Like from lithium fluoride till lithium iodine, it is getting decreased. Like from lithium fluoride to lithium iodine, it's getting decreased.
But what about the group? I'm talking about the group. Look at this
Like,
second box.
but in sodium fluoride, the lithium iodide is getting increased again. But from NaF, like NS from NaF to NaCl decreasing, NaCl to NaBr decreasing, NaBr to NaI is getting decreasing. Then again from NaI to KF is getting.
Sam, just try to listen again. Sodium is fixed.
Yes.
Chlorine, chlorine, bromine, iodine.
Yes.
Now look at this column. Look at this column and let me know the value is increasing or decreasing.
Decreasing 788,
And
678.
what about fluorine, chlorine, bromine, iodine? What group they belong?
Let me open the periodic table. Tell you. Let me open the periodic table.
Yes.
Nothing. I let me open the periodic table. Okay, I'll tell you then. Periodic table actually. Wait a minute, sir. First, 1 minute, sir. Your cat is down.
You can print a copy and put it in front of you because this is ultimate to be there.
Yes, yes, yes. Yeah, right. I'll put the periodic table then. 1 minute. Here's a periodic table.
Why you're taking so much time?
Yeah, I can't find a periodic table. I can't find a periodic table on the chat. I can't find it. That's why.
The documents now.
Actually, I don't have the documents saved. I got it now. Yeah, it's fluorine, iodine, chlorine, bromine, iodine. No, wait a minute. Sir, it's in group number 17.
So it means if I go down a group, what's happening? If I'm
It's
going down a
decreasing.
group,
It's decreasing.
it's decreasing. So
Yeah,
what is the
decreasing.
concept? Look at
Down a
the
group.
down a group, as the ionic radius increases, the
Yes.
lattice enthalpy becomes
That is entirely
less,
because exothermic.
less exothermic. In simple term, it decreases. This is a way, again, chemistry is formal.
Yes.
Again, chemistry is a formal subject. So the chemistry says less exothermic. It actually means decreases. But
Yes.
they want people to write in this format. So now you have to copy this screen.
Okay. My father was asking, did you watch the match today? Or when you was
How was the match?
It is drawn because of rain.
Hmm.
Barish. You watch cricket otherwise?
Let's see.
Many of my friends are going for improvement exam in October, November.
Sorry,
Many of my friends are going for AS improvement exam in October, November.
in here a lot of people are this thing.
Yes, but it is again a risk. You will waste your time for A levels then.
But you need grades, na? You
Go down a group.
yes. If you go down a group, if you what is the concept? If you go down a group as the ionic radius increases, the lattice enthalpy becomes less exothermic. So it means that the lattice enthalpy is getting less, so lattice is getting weaker. So it
Yes.
is easier to break a lattice as we go
Go
down.
down a group.
You have to copy this now. So it
Yes,
means if
copy.
you go down a group, lattice is less strong.
Okay. Sir, where is the problem? Like, what are my positive points and what are my negative points?
Sorry,
What are my positive points and what are my negative points?
we can discuss it later, but for the time being, we should focus on our first chapter. Let's see how our first chapter works in chemistry.
Like, I can do no, like, there's
And
nothing,
we
no
can
way that
sit
I
and
can't.
we talk about that. Na? I have already given you, I think I can send you again the list of this
Okay.
plus
So,
minus
like
point.
you said no one time that Wissam takes time to understand things and all that. You said no.
The main thing I told you always that chemistry, now we are talking in sense of chemistry. Now we are not talking about in sense of physics.
Yes.
Chemistry is
My
a
old friend.
chemistry is a reading subject. Chemistry is a reading, it's a memory subject. Now, semi-qualitative treatment to measure enthalpy change. It's not an actual measurement, it's
Yes.
like a comparison. So just like you say paper 1 was
Yes.
harder than paper 2, it is called relative measurement. So this is called semi-qualitative treatment of to measure enthalpy change. You have to give this heading now.
I'm copying it. You teach maths also?
Yes,
Both O levels and A levels.
yes.
Okay. Next slide, please.
Now look at this screen. This is a formula. This is a qualitative formula. LE means lattice enthalpy. Now again, some physics is needed here. Lattice enthalpy is directly proportional to the product of the charges and inversely proportional to the separation between the charges. So it means if the lattice contain bigger charges +2, +3, the lattice will be strong. If
Yes.
the ions are bigger, if the
Yes.
are bigger, they are separated, lattice would be weaker.
Yes.
You have to copy this.
Yes. Copy this. This also K plus is what K minus is what this also I should copy.
Obviously, you need to copy everything because the thing is the this is actually a type of the parameter what each letter means.
Okay, okay, okay. Copy. It's very hot in Dubai. Very hot. Copied, sir.
Now these are lattice enthalpy. These are the values of ionic charge, ionic sizes, and these values are given when they are needed. Now, for example, I have NaCl and MgCl2.
Yes.
If the ions are bigger, remember this concept. I repeat this concept I told you earlier. If the ions are bigger,
Yes.
if the ions are bigger, lattice is weaker.
Yes.
Bigger ions form weaker lattice. Acha, what about the charges? If the charges are higher, like +1, +2, +3, Bigger charges form stronger lattice. So can you
Yes.
repeat the concept? Bigger charges form stronger lattice
We can
and
have some strong.
smaller ions form stronger lattice.
Yes.
Na+1, Mg+2. Who will form a stronger lattice, Wissam?
A stronger lattice Mg+2.
Yes, very good. Because bigger charges, remember the
Yes.
concept, bigger charges form stronger lattice.
Yes.
Smaller ions form
Small
strong.
ions of weaker lattice.
No. Smaller ions are more powerful in attraction. So I
Yes.
repeat, bigger, greater charges
Yes.
plus smaller ion gives you stronger lattice.
Yes. Okay.
So I want you to please repeat this pair with me because this pair is still giving some problem.
Yes. Bigger ions from stronger lattice.
Greater
Smaller,
charge,
greater charge. I will wrote down also this one. So,
greater charge
yes.
plus smaller
Let
ion
ions.
gives you
So, lattice. Stronger lattice.
stronger lattice. Now we reverse it.
Now, smaller charge plus greater ion give you weaker lattice.
Yes. So if we reverse it,
Yes. Yes.
if we reverse it,
Yes.
smaller charges plus greater
Ions.
ionic size,
Yes.
it will give you
Weaker lattice.
now copy this,
I copied it already.
copy this.
I copied.
Oh, this is the second line, it's the second sheet. I've copied it also.
Yeah, I've copied it. Yes.
Okay. So the famous example which is there is the example of sodium chloride and magnesium chloride and
Yes.
magnesium oxide also. So
Yes.
magnesium oxide lattice enthalpy is much greater than sodium chloride.
Okay. Okay.
So now look at this example, delta H
Delta H.
lattice of MgO is much greater than delta H lattice
H lattice.
of sodium chloride.
Yes.
MgO
Yes.
is doubly charged and sodium chloride is single charged.
Yes.
Secondly, Mg+2 is smaller than sodium+1.
Yes.
Mg+2 is
Yes.
smaller than Na+1.
Yes.
Now you have to copy this.
Okay. I've copied it already.
So we have made this concept and now measurement of enthalpy change. You have to copy this screen.
Okay. You know, the site Save My Exams for practicing. Save My Exams site, Save My Exams.
Sorry.
You know, one site for practicing Cambridge, Save My Exams, one site.
It's a good
Yeah,
website.
but my friend is saying in academy like Save My Exams is finished now. Like they're not providing for A levels now. It's finished now. They are saying
No, they are providing, but obviously the I
it's finished.
always favor one thing. One past paper book is enough. And if
Yeah,
you
no, no. Yeah, no, because my academy saying no, they are not providing. The Save My Exams is finished. They are saying. That's why I wanted to confirm with you also. Is it correct?
need, they have Cambridge papers there.
Okay, I will check after the class. I will
No,
check after the class and inform you. If they are not there, so please guide me regarding that.
but I think I had shared some files for you there. I think I had shared. I'm not sure if I did, but they have material on. They have good material on for this A level.
Yes.
Now, measurement of enthalpy change. These type of topics actually appear in paper 5 because
Yes.
this is a lab related topic. Lab related topics come in paper 5. There are two methods. One is the indirect method using Hess's law, which comes in paper, which mainly comes in paper 4. Direct method using a calorimeter, that is actually paper 5 working.
Okay.
Hess's law is the source of everything here. It's a main topic which have to be remembered. Now you
Mm,
have to copy this screen.
okay. Copy. I'm going. Sir, can you go back? I will copy one thing. One is left. You can change now. Yes, yes, I copied.
Now, direct method using a calorimeter. Calorimeter is a heat insulated container. Inside the calorimeter, you can conduct the experiment. Remember,
Yes.
experiments do not come in paper 4. Experiment come in paper 5. Okay. Now, this is called calorimeter. We put all the reactants and we allow the reaction to proceed. And we use this O-level physics formula. O-level physics formula, Q is equal to MC delta T, which
Yes.
will later convert into enthalpy change. Now, give this heading.
I'm giving one minute.
I have given heading.
I'm giving weight. You can change.
I have to copy this.
Okay. Yes. All of this?
Yes.
UMC. You can change, sir. Sir, you can change.
Okay. Now, quantitative treatment, Born-Haber cycle. The main topic of this chapter is here now. Lattice
Bond
enthalpy is the main topic, and Born-Haber cycle is the main calculation, the main topic
calculation.
of
Yeah,
this Born-Haber
it's
cycle.
basically calculation part. It's basically
Yes.
the calculation part. One have a cycle. I have copied it. You can change.
Born-Haber cycle is a modified version of Hess's law. It is a specific for ionic compounds. So in A2, you have to deal with ionic compounds. In AS,
Okay.
you had managed covalent compounds. So in
Yes,
AS chemistry, so make the first concept. What is Born-Haber cycle?
is a
Born-Haber
modified
cycle is actually
modified
a modified version of Hess's law.
Hessian flow. Yes,
And practically, Hess's law is this version is used only for ionic compounds.
yes,
Okay.
sir. Yes, sir.
Okay, now you have to copy.
I've copied it. Copied it, sir.
Steps of lattice formation. This will be our connecting concept for O level, how a lattice is formed. Both
Yes,
the elements become gaseous atoms separate from each other. One atom loses electron and it becomes a positive ion.
yes.
Second atom gains that electron and becomes a negative ion.
Negative ion. Yes, of course.
Charged gaseous ion attract each other and they come close until a solid lattice is formed.
Yes,
This is
sir.
very important sheet. If you remember that, you can manage the lattice formation steps. You have to
Yes, sir.
copy.
Yes, because it's common. Like whenever there's positive ion, the atom will lose electron. Whenever there's a negative ion, atom will gain the electron, and oppositely charged and always attracted each other, or like
It lattice
opposite.
formation.
Yes,
Lattice formation
yes,
needs actually oppositely charged ions.
yes. I'm. Should I copy this also? Where I'll copy it.
Yes, you have to copy this screen.
Yes. आ जा रहे आप और हम दोनों चले सही Sir, I copied it.
So both the elements become gaseous atoms separate from each other. This is atomization. Then, sorry,
No problem.
one atom loses electron and becomes a positive ion. Second
Yes.
atom gains that electron and become
And second,
negative
gain
ion.
electron becomes a
Becomes
negative
negative.
ion. Negative ion.
Now look at this simulation that X and Y are two ions. They both are atomized. Then they transfer electron. After that, one is positive and one is negative. They join to form a lattice.
Yes,
You have,
sir.
you have to copy this concept sequence.
Okay. I should copy a new fresh page because I've written something. I'll copy. That is, I'll copy a new fresh page.
It should be on one page.
Yes, I'll start making another page because space is not there more. That's why. Yes, copied.
Now, this is called an ionic lattice. One is positive, one is negative. So when you allow them to move, they will come together, they will come and attract each other.
Yes.
NaCl, for example, Na loses an electron, become Na plus, and chlorine gain an electron, become chlorine minus. So
Yes.
in between, there is a force of attraction, which is ionic bond origin. You have to copy this example.
Copied. Yes. Copied. Copied.
Energy changes in a lattice formation. What are the energy changes? That there are three main energy changes: atomization,
Yes.
ionization, and then
Ionization, attraction, and then lattice formation.
but attraction is not an energy change. It's a consequence of oppositely charges. Now you have to give this heading.
Okay, sir. 1 minute, sir. Copied.
Atomization, which is always endo. Ionization has two parts: ionization enthalpy, which is endo. Electron affinity. Remember, first electron affinity is exo and second electron affinity is endo. You have to copy this energy line.
Yes. Copied.
So we are ready for the final step and ionization enthalpy. Remember that when a lattice is formed,
Yes.
you first
Yes.
have to separate the elements.
Yes.
Then one atom loses electron and one atom gains electron.
Electron. Yes.
Okay, and the oppositely charged ions attract each other, and this is the source of lattice formation.
Okay.
So we stop here and we will inshallah
Tomorrow.
continue in our next class. Allah
Goodbye.
Hafiz.